technology. I am here to present you a video lecture on engineering graphics. So engineering graphics, what is engineering graphics? It is the language of the engineers. Engineers like civil engineers and mechanical engineers, they can't communicate their concepts with the help of diagrams which is accepted universally. So there must be certain standards which are to be followed universally while drawing any engineering diagram. The standards are right from the usage of the pencil, the paper, and so on. So here I'll be giving you briefly, I'll be talking about the various syllabus provided by our university. So our syllabus is having 5 units, in which unit 1 you'll be learning about the curves, the different conic curves, and how to draw the conic curves. And again in unit 1 you'll be learning about freehand sketching of or getting the different front view, side view, and top view of any three-dimensional object. And in unit 2 you'll be learning about projection of points, lines, and planes. Unit 3 about projection of solids. And unit 4 is about section of solids and development of surfaces. And in unit 5 you'll be learning about isometric and perspective projection. So while I was talking about the syllabus, I was using a term which is known as projection. So most of you are familiar with that, but a student of engineering graphics, it will be a new topic because we are using the term projection to get a single two-dimensional view of any three-dimensional object. So here in this slide, it is mentioned as first angle projection. So what is given there in this object, in this method, the object is assumed to be situated in first quadrant. So hope you all know about the various quadrants, 4 quadrants, first, second, third, and 4 quadrants. In that 4 quadrants, you'll be able to see 2 lines, 2 referent axes. One is the horizontal axis or the x-axis, and the other is the vertical axis or the y-axis. So imagine that if these 2 lines, if they are replaced by 2 planes, the vertical line is replaced by a plane, and the horizontal line again it is replaced by the plane. The vertical line will be replaced by a plane which is known as the vertical plane here, and the horizontal line is again replaced by a plane which is known as the horizontal plane. So if these lines are replaced by planes, and if the object is situated in the first quadrant, here this is the object. So what is projection? Projection is nothing but getting the different views of this object either on the vertical plane or on the horizontal plane. And here at the right side you have one more plane that is known as the picture plane. There also you are able to get a 2-dimensional view of this object. This is a 3-dimensional object. So this is known as projection. So in this projection here it is mentioned as first angle projection. So based on the quadrants where the objects are present, you can classify the projection as first angle, second angle, third angle, and fourth angle. While 4 angle of projections are possible, only first angle projection and third angle projection are followed. In India we follow first angle projection. So what is a front view? Here FV stands for front view. Front view is nothing but projecting the object. Here this is the 3-dimensional object. It is projected to the vertical plane. If the object is projected to the vertical plane in first angle projection, you get a front view that is known as the front view. That is the image of this object obtained in the vertical plane. What is top view? If the object is projected from the top, that is the image of this object, you are getting on the horizontal plane. Object is placed here. If you are seeing right perpendicularly from the top, you'll be able to see this 2-dimensional rectangle that is projected to the horizontal plane, and this is the top view. And side views, if you are seeing from the left side, it is known as left side view, and the image of this object is obtained on a plane which is known as the picture plane, and this is the side view or the left side view. So here in this diagram, this 3 as a 3-dimensional objects, 3-dimensional mirrors, you can assume them as mirror over here, here, and here. And if you are drawing this mirror such that if you are folding this down, to 90 degree. Rotating the horizontal plane is rotated to 90 degree down. Again, the top view goes down. Here is an XY reference line. Above that you will get the front view, below that the top view, and again this plane, if it is moved for 90 degree, rotated for 90 degree to the back, again the left side view goes to the right side of the front view. Therefore, in first angle projection, the front view is drawn above the reference line, the top view below the reference line, and the left side view to the right side of the reference line. The next slide we'll be seeing another example. So look at this diagram. Here the object is a three-dimensional object which is having three patterns representing the front view, the top view, and the side view. So here is the final diagram which you are getting as the front view. Now compare this diagram with the pattern which is pattern diagram which is drawn here. So if you are seeing from the front, I have already told you that it is the image which is obtained in the vertical plane. This is the vertical plane. Here you get an image where the lines or the two-dimensional rectangles or this L shape having similar patterns are drawn. And if you are seeing from the top, what is the top view? It is the image of the object which is obtained in the horizontal plane over here. And here also, if you are seeing from the top, this is seen, this pattern is seen, this is seen, and here it is also seen. So all these three views are collectively drawn so that you get the top view. If you are seeing from the left side, again this pattern is obtained as the left side of view. So here you are getting the front view above, top view below, and the left side view to the right side of the object. In this slide you are able to see a square, it's a cube, and there are projections from that cube. One at the front, top, right side is also there is a projection, and at the left side. So for front view you are able to see this smaller square and the square which is surrounded that smaller one, and above that you are able to see this rectangular part, and there is a projection at the bottom also. Similar to this rectangle, there will be a projection below the second square. So that is why you are able to see one square, smaller square, bigger square. Above that there is a projection over here, rectangular projection at the bottom, and left side also there is a rectangular projection, and the right side also there is a rectangular projection. And similarly at the top, I have told you earlier that the front view should be drawn above, top view should be drawn below, and the right side view should be drawn to the left side view should be drawn to the right side. Here they are getting the left side view. For left side view you get a square, smaller one, bigger one, projections above, below, and both the sides. Here all the three views are similar here. In these slides the three views are marked by different colors. For example, for front view, if you are looking from the front, you are able to see this pink color. And if you are looking from the top, you are able to see this green color. Therefore, if you are looking from the front, this pink color, and from the top, this green colored object. If you are seeing from this side view, you are able to see the blue colored object. In this example, the diagram has a semicircle or a curve, and it also has a taper. If you are seeing from the front, you'll be able to see this curve. If you are seeing from the front, again you are able to see this taper. But if you are seeing from the top, you are not able to see the curve. So in the front view, the curve is drawn, and also the taper is also drawn. But from the top, here no part is curved or no part is tapered. Again, if you are seeing from the side, you are unable to see this curve. This curve is seen only from the front. If you are standing to the right side exactly perpendicular to it, or to the left side, if you are standing and viewing it exactly perpendicular, you are not able to see these curves. So in one of the views you are able to see the curve, and also the taper. And here you are having some lines which are drawn as dashed in the left side view and also in the top view. So what does these dashed lines represent? For example, if I'm taking this top view, if I'm seeing from the top, there is an edge over here. If I am seeing from the top, this edge is visible only up to certain part. After this part hides the edge, and again I have to represent these edges. So for drawing hidden edges, we are representing the hidden edges using dashed lines. And again there is an edge over here, vertical edge from here, and it runs up to the next end. If I'm seeing directly from the top, this portion will hide that edge. So to show that one, you are drawing that edges as hidden lines. So far I was explaining you briefly about freehand sketching that comes as a part of unit 1. Hope you found that interesting. Similarly, you have projection of points, lines, planes, and you are supposed to draw the three-dimensional object as itself in isometric projections. And I know that it will be quite interesting if you are learning the subject with interest. Thank you. All the best.